All right, so there's nothing on the screen but the roll sheet. Switch it over again. I'm always just looking at my screen. All right, V equals 6 pi ZH plus 5 pi Z squared. All right, just made it a little bigger there. So we're trying to solve for which letter? Which letter do they want from us?
H.
They want the H. They want the H right there. So the H is saying, I want, here's the wall. Here's the wall. The H is saying, I want to be alone. So, what do we do? It's kind of like keeping your eye on the ball, right? You got to stay focused on, there's so many letters everywhere. Which one's the H? This one right here. Right? You good? Get that H alone. What are we going to do?
Add the 6 and the 5 pi Z.
Well, remember the stuff that's right next to the ball, we save for last. It's like peeling an onion. That's my other analogy. You start from the outside, outer layers work down to the middle, right? So I'm going to get rid of this chunk first. After that's gone, then I'll think about the stuff right next to the H, the 6 pi Z. Isn't that how we always solve equations? Always get rid of the outside stuff first, and then lastly, get rid of the stuff right next to your letter, whatever that letter is, in this case H.
Where do we start from
It's not left to right. It can be right, it can be left. There's no rule there.
Okay.
It's just furthest away to closest. That's why I make the onion analogy. Outer layers could be either side, right? Down to inner layers. So you want to think about what's closest to that H is 6 pi Z. That's going to be last. Right? Whatever's closest is last by dividing. But whatever's furthest away, you do first. So this whole 5 pi Z squared chunk, subtract it over, huh? Is that good? Subtract it, because it's added, right? We always do the opposite. So it's added to both sides, so I subtract 5 pi Z squared. And whatever you, right? Because that'll get rid of it, won't it? Does that make sense? See how we're trying to get down to the edge? We're peeling the onion, getting down to the edge. And whatever you do to one side, you have no choice but to do the same thing to the other. Is that good to there? So then we get V minus 5 pi Z squared is 6 pi ZH. We good to there? And here's the ball. Keep your eye on the ball. And H is saying, the ball is saying, I want to be alone. So what do we do now? To get H alone? Divide by 6 pi Z, right? Divide, because that's all multiplied, right? Everybody see why? The first chunk was added, so I subtracted it. The next chunk is multiplied, so I divide it. We always do the opposite operation. Anything added, we subtract. Anything multiplied, we divide, huh? Is that making sense? So I divide both sides by 6 pi Z. 6 pi Z gone. H is alone. H is all alone. Are we good?
So why did that turn into V minus 5? Wasn't that an equal sign?
What's that?
Wasn't that an equal sign?
There was equals in the middle. So these were the two sides. And to get rid of this added 5 pi Z squared, I had to subtract. And whatever you do to one side, you have no choice but to do the same thing to the other to keep the balance. So I subtracted both sides. That's why it came down as minus.
Okay.
Yeah, so here's the wall. So that's why I'm putting the line there, because that's how you want to look at it. You want to look at it left side, right side, and I'm doing the same action to both sides. And I'm doing whatever action gets rid of that piece. Does that make sense how I got rid of that piece? Did the same thing to the other side. And then I divide it, because that piece, the next piece was times, so I divide it on both sides. And I'm done right there. Why? How do I know I'm done? H is alone. There's nothing more but H on his side. I got him alone. How are we doing? Is that making sense? Other things I can help with? Do you know, by the way, I don't know if you're wondering, but you can't cancel any of these pi's or z's or anything. It's because of the minus sign. When you have pluses and minuses, things are like glued together. Makes them kind of a package deal. The analogy I always give is shopping at Costco. We have 5 kids, so my wife shops at Costco. What happens at Costco? Bulk, like Sam's Club, Costco's warehouse stores. You buy in bulk, right? So if you try to grab one spaghetti sauce off the shelf, it'll be plasticed or taped or something to another one. You can't take your scissors to Costco and just chop. Say, thanks, I just want one. That's the whole deal. You buy a lot, you get a little bit cheaper deal. So that's what pluses and minuses are like in algebra. Pluses and minuses connect things, glue things, make them a package deal. So as you're looking at that minus right there, you see if that was times, if that was v times, let me change that for just a moment. If that was times, then I could totally cancel the pi and one of the z's. I could totally do that, I would do that. But because it's minus, or plus would be the same issue. Plus or minus, what was it, minus? Yeah, minus. It's glued together. What do I mean glued together? Which means that whole thing is, this is a package deal. Which means what? Which means you buy the whole package or don't buy anything. All or nothing. Does that make sense there? All or nothing? Yeah.
I think one thing that's kind of confusing is that you can't combine, it looks like they're like terms, the 6 pi z.
Oh, these two?
Yes, but they're not.
Good. Thank you for that. You're right. Yeah, these are not quite, they're almost, huh? These are not quite, we can't go 6 and 5 is 11, right on the money, because they're not quite like terms. What are like terms? Same letter pattern. Identical letter pattern. They're close, but this one has a z squared, and that one just has a regular z. And of course this one has an h, and that one doesn't have the h.
Yeah.
So if there's any difference in the letter pattern, they cannot combine. They're not like terms. Like means exactly like in the letter pattern. Only the numbers, yeah. Exactly like in the letter pattern, yeah. So you can't do that. What's that?
Like the positive or negative sign, even that would throw the whole thing off? It would make one of them unlike the other?
No, signs in the front are fine.
Okay.
Yeah, it's just the letters. As long as the letters are exactly the same powers, same everything, if the letters are identical, that's like terms. If the letters have any difference, then you can't combine them. Yeah, good. And so we can't cancel anything here, right? Because this is a package deal. It's all or it's nothing. We can't cancel all of it, right? There's no v down here. So we cancel nothing. So I kind of scribbled it all up now. Let me put it back the way it was. So the final answer then, we cannot cancel anything over here. 5 pi z minus, or v minus 5 pi z squared over 6 pi z. That's just it. We can't simplify that at all. We good? How we doing? I think. Okay, so we got this tank. A certain species of fish requires 1.5 cubic feet of water. Basically, long story short, they want us to find the volume of that tank. Do you want me to make that a little bigger? Will. Can you see it okay? Probably not, huh? So we're good to there. So that's number 12. So they have that big cubic thing, and they want us to find the volume. Like how much inside space is there in that shape? What's the volume of that shape? Anybody know how to find the volume of a 3-dimensional shape like that? Yeah. The volume is just the 3 sides multiplied. Call it length, width, height, or whatever you want to call it. It's the 3 sides multiplied. Exactly right. Base, whatever you want to call it. Yeah, it's basically just going to be these 3 numbers multiplied. That's how you find the volume of a 3D shape. Just multiply those 3 sides. So that's going to be 3. It doesn't matter what order. 3 times 4 times 3 or whatever order. I think that's 36. So 36 is the volume there. 36 is the volume. Now, that's not their whole question. No, that's the first part. And then I think what they say, each fish needs one. Each fish needs 1.5. Now, These are cubic feet. I don't know if you know, because we multiplied feet times feet times feet. So that's feet cubed. You don't have to write that. It's not that important. Anyway, each fish, to be a healthy, happy, thriving fish, needs 1.5 cubic feet of space. So how many fish can fit in that tank happily? We don't want unhappy fish. Yeah. Did y'all see that it's going to be it's going to be 36 divided by 1.5? Like how many times 1.5 goes in there? Which is I don't know. 24? 24 what? 24 what? Fish. Remember, that's how many fish. You guys are all doing this cubic this and that. It's just fish. 24 fish. Right? 24 fishies can fit in that tank. How we doing? Is making sense?
That's the formula for any three-dimensional shape?
No, yeah, good question. No, it's just for like if all the sides are like rectangles. Yeah, it gets more tricky for other ones. Yeah, good question. Yeah, and you don't have to know them all. I would give them to you on an exam. Like on an exam, I would tell you the volume's length, width, height. You know, honestly, I would give you this formula, but then you could crank out the rest from there. Yeah, I don't expect you to memorize those kind of formulas. Are we good on the cranking out then? That makes sense? Which one is actually more pizza? Now, when they say like how big a pizza is, this is a 20-inch pizza or whatever. Do they mean what do they mean, radius? Did it say? Honestly, I'm a little confused. It didn't say, did it? When they say this is a 20-inch pizza, what do they mean? Let me draw a little pizza here. Don't they mean like all the way across is 20? Isn't that what they mean when they say a 20-inch pizza? They mean all the way across, right? And so when we're figuring out, and over here, we're going to have two smaller pizzas. In fact, let me try to draw it a little more true to form to be more helpful. So that's the best I can draw right there. 20 inches across. And then over here, well, that's not so good. I told you, you right when my art career ended, didn't I? Didn't I say that already in here? 7th grade, Mr. Duran's class, I got a C in art, and I was trying. And that was the end of my art career. I think he just didn't appreciate my eye for art. It was just too advanced for Mr. Duran's tastes, I think. All right, so that's what they're asking us. Which one's more pizza, the 20-inch pizza or the 212s? Okay, so how are we going to figure it out? Well, to figure out like the total amount of pizza here and, here and here, what do you got to do? You got to find the area, don't you? Because that's how much it is. Do you know what I mean? When you talk about how much pizza, that'd be like if I said, how much carpeting is here? I would need to figure out the total amount of area. Same way there, it's the area of the pizza. You eat area, right? It's actual area. So how do you figure out the area inside of a circle? Does anybody know the formula for the area inside of a circle? Pi r squared, yeah, good job. Pi r squared. Remember that old formula? Have you heard that one before? Pi r squared is the area inside of a circle. What's pi? 3.14, yeah. Do you know that? 3.14. So I'll put that. So that's 3.14. Can you read that okay? Is it too small? And then what's the r? I'm going to square r. What is the r?
It's half of the diameter.
Good job. So what's it going to be for this first one? 10, yeah. So if 20 is all the way across, then from here to here, that's r for radius, and it's just going to be 10. So this is 10 squared. Is that good so far? I don't want to race ahead too fast. So y'all seeing what I'm doing? So again, you don't have to memorize this formula. I would give you this formula. I would say, because they did. I'll do exactly what the homework did, and they gave it to you. They said, use this formula to find the area. 3.1 pi is 3.14 times r squared. Now r is just halfway because it's radius. You're familiar with that with a circle? The radius of a circle is just halfway from the middle to the edge. Anywhere you go middle, edge up, diagonal, whatever, it's always the same. It's 10. It's half of all the way across, which is the diameter. So the radius is 10. So if you use your calculator, 3.14 times 10 squared, I'm betting you get 314. That's an easy problem because 10 squared is 100. It moves the decimal 2 places, right? Okay, now for the other one, how about this one? What's going to be the area of each of these pieces? It's going to be the same thing. It's going to be pi r squared again. So pi r squared for this one and pi r squared for that one. We good? How we doing? Pi r squared. So pi 3.14 times r. Now what is the r for these little pizzas?
6.
Yeah, it's just halfway. R is just 6. I don't know if you can read my right. Let me better change the color there. So yeah, from the middle to the edge, r is just 6, huh? Because radius is just halfway. So 6, but it's squared. Same thing over here. 3.14 times 6 squared. Let me try that again. Is that good? So use your calculator, and I don't have one with me. 6. I can't do that one in my head. It's like 110 or 113. Thank you. 113.40. 113.04. Thank you. And this one's also 113.04. So if we add them up, we're going to add them up, right, to find the total amount those two pizzas are. 226.08. So 226.08. What are the units on that? Square inches, right? Because area is always how many little squares. So it's square inches. And this one's also square inches. You don't have to write the units, but you're actually saying how many inch by inch squares could there be filling up the pizza. There'd be 113 little square inches filling up each of these guys, and 314 little square inches filling up this guy. So which one is bigger? Yeah, the 20 inch. You realize that? It's actually bigger. What's that? Yeah, maybe. Huh? Yes. Is that making sense? Good? Questions I can answer? How are we doing? It's all making sense? Can I add it so and so this is specifically particularly hard section. All right, perimeter of an equilateral triangle. So first off, let me write that out. Perimeter of an equilateral triangle is 8 more than the perimeter of a square. And the side of the triangle is 5 inches longer than the side of the square. And the side of the triangle is 5 more. This is number 14 here. More than the side of the square. Okay. All right. So, you tracking with all that? It's just like a trick little problem here. So, okay. So we have a triangle, equilateral triangle. What does equilateral? It means all three sides are equal, huh? they're saying that. They're giving you that hint. So equilateral triangle. What his sides, and then we're talking about the sides of the square. So let me come over here and do the square. So we're talking about an equilateral triangle and a square. All right. Y'all have any ideas? What should we do? Do you like these? They're like little puzzles.
You said just put them together and make a house.
How about, yeah, Carla, did you have an idea, Manuel?
It'd be S times 4. 4 times S plus A to get the perimeter.
For the perimeter? Yeah, you're right. You're thinking right about the perimeter equation. It might be easier, because the perimeter is kind of tricky, to start with that second sentence. It's a little easier sentence. So that's one thing that helps sometimes with difficult problems. Start with the easy part first. So what about just this? Just forget about that perimeter. We'll come to the perimeter thing in a minute. How about side of the triangle? Like one side is 5 more than one side of the square. So what do we always do in every word problem? Every word problem. We have an x, and then we have some x formulas, don't we? We have a plain simple x, and then we have like x plus 10 or x minus 3 or something like that. So do you see how this sentence is telling us about the x and some other x formula? What's it telling us?
That tells us x equals square.
The side of the triangle is 5 more. So what do you do when they say, in any word problem, what do you do when they say 5 more?
5 plus.
X plus, we're always going to use x, right? It's not, so it's x plus 5, 5 plus x either way, but you got to have the x in there too. X plus 5. That good? They say 5 bigger, 5 further, 5 more, 5 larger. X plus 5. Those are just all different ways of saying x plus 5. So that's going to go where? It's the side of the triangle. So that means this is x plus 5, and they're all the same, huh? So they're all x plus 5, and then somebody's going to get a plain x. Always, every word problem, somebody gets a plain x. Where's the plain x going to go? For the square. X, 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 x. Does that make sense? Right? Because you got the triangle sides are 5 larger. 5 more. Okay, now let's go to the perimeter thing. So the perimeter of the triangle, hold on. Can we get a formula for the perimeter now of that? How do we get the perimeter of this triangle? Add those 3 up. So I'll do that in a second. What is always? Equals. Like this is the left side. I better write here instead of just point. This is the left side. This is the equal sign. And then what comes after is the right side, huh? Is that good? So what's the left side? Perimeter of the triangle. So I'm going to totally run out of room here. Let me just put it up here. That's x plus 5 plus x plus 5 plus x plus 5. Good there. Perimeter of the triangle, the 3 sides added up. And then equals 8 more than the perimeter of the square. 8 more. 8 more. There's 8 more again. What do we do with that? Add 8. Huh? That'll equal 8 added. You can add the 8 in the front or the back. Doesn't matter. 8 more. 8 added to. 8 added to what? 4x. Yeah, good. The perimeter of the square is going to be 4x because it's just x plus x plus x plus x. How are we doing? There's our equation. So x plus 5, x plus 5, x plus 5, the perimeter of the triangle, equals 8 more than 8 added to 4x, which is the perimeter of the square.
So
Now I got to...
The part of the problem was the first part of the
Yeah, I started with the last sentence to put my x's and my x plus 5s, yeah, because that just looked easier.
And that's the first part of the equal sign, right? The left side?
Yeah, whatever comes before is the left side, and then the equal sign, and then the right side. Yeah, totally. So, all right, so let's take this now and go to a fresh screen where we have some room here. So we have x plus 5 plus x plus 5 plus x plus 5 equals 8 plus 4x. There's the wall. Is that making sense there? So I just added those up. There's my equation. Can you solve that thing? For x there? So x plus x plus x. Yeah, because 1x, 1x, and 1x, that's 3x. And 5 plus 5 plus 5? 15 equals 8 plus 4x. Now, you're all lean, mean, solving machines at this, but you know how to solve when there's x on both sides. What are we going to do when we have x on opposite sides of the wall?
To the lesser of the opposite.
Get rid of the lower one, huh? Get rid of that lower one. Yeah, get rid of the lower one. So the lower one is the 3x. So we subtract 3x. Cancels that out. Bring it on down. 15 is 8 plus plain x. Is that okay? Am I racing ahead? 4x minus 3x. So how are we going to solve for x there? Yeah, last step. Subtract 8. So we bring it down. X is 7. X is 7. Now, is that our answer? Maybe. It's the key, right? But you got to go find out what door they want you to unlock. That's the key. We can answer any question now. Let's go see what they want from us. What do they even ask for? I don't know. It's all scribbled up. Here, let me get this out of the way. That says, the side of the triangle. They want the side. Is that what they want? Find the side of the triangle. Yeah. They just want the side of the triangle right here. So, okay, let's go back. So what's how do you figure out the side? Let's look at the picture there.
That's 12, x plus 5.
Yeah, right. So the triangle sides, they're all x plus 5, aren't they?
Yeah.
So, and we have the key. What was x? 7. So x is 7. So I'm going to plug that into side of a triangle is x plus 5. Grab that 7. Put that in. So that is 7 plus 5 is 12. 12 is the answer. Each of the triangle sides is 12. That was a hard one. Questions on that one? We good there? Is that making sense? Questions I can answer? All right, so can you read that one? Longest runway at an airport has the shape of a rectangle and an area of something big. The runway is 180 feet. What did I get? 180 feet. How long is it? So basically, we have a runway. The rectangle. Let me just write it out here for you. The rectangle area is 2,181,600. It's 180 feet wide. How long is it? We just divide. Are we good with just dividing there?
Yeah. We get the formula.
That's right.
The formula area equal side by base for high, or I don't know how to say it.
Totally. Yeah, you're totally right. Area. Usually they say length times width, whatever you want to say. But and I don't need to write that whole formula thing. If you guys are good and you just know, just divide. Totally. That's totally right. And you can just do that. So the rectangle area. So how about I show more formal? But if you want to do it more casual, that's okay too. So the width is 180. So if you want to be kind of formal about it, the area is that, the width is that. And then how do you solve for L? Just divide. But if you knew that from the beginning, then don't even bother messing with it. It's fine with me if from the beginning you just went ahead and divided. So on both sides, boom, like that. So if you just divided and that's more confusing for you, don't worry about it.
just divide, it's all good. Of course, I don't have any idea what that comes out to be.
120,
120, 120, like that?
12120.
2120, 2120, like 12,120?
12,120.
All right.
Yeah.
All right. But you got to quit saying it in Spanish, Manuel. I'm sorry, I'm just kidding you. All right, we good? We all good there?
Yeah.
All right. So you can just divide. I probably made more of that problem than I need to. So you can just divide.